the derivative of the integral is just going to be f of x. So really, you're trying to figure out when f of x is greater than 0.
Is it f of x or f of t? Or does it matter?
F of x.
So 0 to 3.
It is f of x.
Mm-hmm.
But
So-
is it still just the graph?
So when you look at this function now, it still ends up being you're just still looking at the graph because the t and the x are the same.
Okay.
All right, or t equals x. So when you look at this function, when is it greater than 0?
0 to 3.
From 0 to 3. So on what interval is it increasing? Yeah, well from 0 to 3
Nice.
for part B.
And you say because f of x is greater than 0 in this,
Still give the same reasoning like you did before.
but it's f of x in this case.
Well, no, you would still just say because g prime is
Oh,
greater. You can still just use that notation. Yeah. All right. I know that looks funny. All right. So then for C, it says where does g have a maximum?
3.
All right. And how do you know it's 3?
Because it changes from positive to negative.
All right. So along the same lines, to find a maximum. If you remember when we found the maximum,
Yeah.
it was when g prime changes from when the derivative changes from positive to negative. That's when you had a max. So in this problem, you're trying to figure out when g prime changes from positive to negative, but we know that g prime, we just said, is the same thing as f. So g prime is f. So f is just this function, just this graph. And so when does it change from positive to negative? Well, it changes from positive to negative values at 3. So in this case, it has a maximum. All right. So g prime, or g, has a max
Can you say G of 3?
at what, x equals 3? Because, and like I just said up here, g prime positive to negative. Alright, but still, like, you're trying to apply what you did before to the same type of problem. It's just now g represents the integral of something as opposed to just the original function. Alright, and then for D, it says evaluate g of, or excuse me, derivative of g at 2.
4.
And so the derivative of g, again, just means that we're talking about really f of 2.
So it's
And f of 2 is 4. So that's just a point. So that's the part that you're going to have to make sure you see. Like, you look at this, the integral of this, but then it's like, if I take the derivative of g, what is that actually equivalent to? If I take the second derivative, like if I said, hey, what is g double prime of 2? So g double prime would equal what? F prime. Oops. Would equal f prime.
Bruh.
Man. Equals f prime. And so then f prime at 2 will be the sharp point, and so it would be undefined, does not exist.
Wow.
Alright?
That's crazy.
So you're still kind of thinking about it along the same lines like we were doing before, but like
Look at
your
that
starting
arc,
point is
Christian.
slightly different.
Look at
You're
that
starting
arc.
with the function f, you're starting with the integral of f, so you're starting with the area portion first, and then working backwards. Because function f would just be the point, the derivative of f would equal, or the second derivative of g would be the derivative of f, which would be that
Right.
slope, and then